So, in yesterday's class, Ritika, the good news is we did not learn anything new. We practiced some of the interesting problems. We had learned about finding out surface area and volume of cuboid, cube, cylinder, and then in yesterday's class we looked at some of the assignments which were tricky in nature, and we looked at how do we approach solving those problems. So I uploaded the video of the class already. You guys, whoever missed this and whoever wants to revise it, please go through the video. You should be able to catch up on that. Today we wanted to pick up a new topic, something even more interesting. Your hand has to be down always.
Should we tape it down?
I'll find a string to tie both of you. Okay. No, so we have Gitesh also. So coming back to the serious point. So today we wanted to pick up a new topic, a more relatable topic to geometry, because we had started geometry. That is called coordinate geometry. Now you all have heard about coordinate planes. Now we are talking about coordinate geometry.
Is that where you draw shapes?
What exactly is that? Any guesses around that?
I think.
Think and tell.
Yeah.
Don't blabber.
I think it has to relate to tracing a shape within a graph. And also, question: are we gonna learn it by 4 concepts?
No, what we will learn that I will teach. My question was, can you make a guess around what is coordinate geometry? What you said was actually right. Okay, let's.
Where you plot like shapes on the coordinate plane?
Exactly. That's what he was also saying. So any other thoughts? When we talk about coordinate geometry, what is your interpretation of that? Arihan? Yeah, sure. Yeah, Vihan. Arihan, sorry, not Vihan.
I thought it would be like we're gonna create more
Yep, pretty much. Any other thoughts? No? You guys are very shy. Ritika, any thoughts, beta?
I was gonna say something similar.
Similar to that? Okay. Now, so as I always claim, Adam, this is a math class. Kung Fu, Taekwondo, everything we'll do outside the class. Okay, that's okay. Sitting here is fine. I don't want you guys to keep fighting. Now, somebody raising hand. No? Alright, so here. Adam, all your smartness and intelligence outside the class. Here we are only doing math, no fighting, no struggle, no contradictions. 50 minutes of undivided attention is what I need. Now, as I said, coordinate geometry. Try to minimize the noise because that helps. Coordinate and geometry. Geometry we all know. Coordinates also we have heard enough. So, when we talk about geometry, what does come to our mind? Line, rays, angles, triangles, parallelogram, trapezoid, rectangle, pentagon, hexagon, circle, whatnot. Okay, these are the parts of geometry, and then we learned about 3D shapes also, where we talked about cuboid, cube, cylinder, whatnot. Now, so geometry part is kind of clear. Now, coordinate geometry. So, Arav and Advik, beta, you guys are.
I remember I sharpened my pencil, but he didn't. That's what I thought.
I'll talk to Daddy, beta, if you force me to. So when you talk about coordinate geometry, we are talking about, see, we know about what is a coordinate plane. When we talk about this being x-axis, this being y-axis. And then coordinate plane is fine. If I try plotting a triangle here, now what we have done, we have brought these two things together. This was my coordinate plane and this was my geometry. We put them together. That's how it became coordinate geometry. Now you will think, how does it actually matter? And the answer is, it does. It does matter. Because now let's say that this was my coordinate plane. And if I have to draw a triangle, what do I need actually in the first place? If I have to draw a line, what do I need? I need 2 points, join them. That becomes a line segment rather. What do I need for drawing a triangle? I need 3 points and then join them together. That becomes a triangle. What do I need for a rectangle? I need 4 points, join them together. That becomes a rectangle. So far, okay, digestible? Yep. So, let's say if I'm talking about a triangle, I'm talking about 3 points. What matters is, where are these points? Are these here, here and here, or are these here, here and here? If they are here, here and here, this is my triangle. If the points are here, here and here, this is a triangle. If the points are here, here and here, this is my triangle. So, points have a point. If your points are in different places, they make different shapes. Points are not pointless. Yeah? Every point is making a point. This is a bad joke. Let's move on. So here, what I'm trying to demonstrate or depict is that you need certain points to join them and make a shape. Who helps you identify those points? That is where coordinate plane comes to our help. If I'm talking about this point, essentially coordinate plane is telling me what is the location of this point. Let's say this 1, 2, 3, 4. This is 1, 2, 3, 4, 5. So this point is 4, 5. Who tells me that? That is coming from coordinate plane. So coordinate plane helps me locate the points that we will use for drawing shapes. So that is how it is becoming. Let's say if I have these 3 points, let's say 1, 2, 3, 4, 5, minus 5. This is minus 1, minus 2, minus 3. So this point is, let's say, minus 2, this is minus 3, comma, minus 2. And this point is minus 5, comma, let's say 2. So now, coordinate plane has told us where these points are located. If I just join them, I got my triangle. So, this is so very perfect. Now every point is located perfectly with the help of coordinate plane. Now when you join these points, you are able to draw the shape. If you have 4 points, you join them, you get a quadrilateral. So far we have not learned anything. I am just helping you guys relate why these two enemies have to be together. Coordinate plane and geometry. They are not siblings, they are not friends. They are totally different, but they are coming together now to help us put the concepts together. Is everybody okay with that storyline so far?
Yeah.
I think
Yes, sir.
Yep.
Yes, sir.
Okay. Good. Makes me feel good. So, Lakshita, since you joined, okay, one very bad example. So somebody says something, okay, you say. Somebody says, what is your name? I'll say, Birendra Kumar. This is one response. Somebody says, what is your name? Birendra Kumar. What do you do with that? That looks kiddish. And I don't expect that to be the case with any of you, because you guys are heading towards high school, almost there. So don't do that. Okay? We have to reflect that we are getting more mature with time passing by. Okay? So that was, and again, see, I'm not trying to put anybody on the spot. I'm a teacher, right? I'm just trying to teach you guys how to think. I would have done the same mistakes when I was your age, probably, and I learned it the hard way. I'm just passing it on to you guys. Okay? Don't get me wrong. Now, coming back to this one, so we understood that my coordinate plane. So for Lokshita, so what we are doing, Lokshita, today is we know about the coordinate planes and we know about geometry. We are trying to find out what is the relationship between these two. Coordinate plane helps you locate the points. What is the coordinate of this point? What is the coordinate of this point? What is the coordinate of this point? So coordinate planes helps us locate the points. If you join these points, what you get? You get a triangle. This is geometry. So coordinate plane and geometry together is what is called coordinate geometry. That's what we have discussed so far. Okay, so you have not missed much. Yeah.
Will they make us do a decagon?
You can do decagon, you can do nanogon, pentagon, whatever it is.
So we're just doing 4 quadrants only?
Huh?
So we're just doing 4 quadrants for the
Coordinate plane has 4 quadrants only. So I will not try giving birth to a 5th quadrant here for the sake of simplicity. Okay? Alright, let's move on. So now we know what is coordinate plane, what is coordinate geometry, conceptually. But my problem is not solved yet. Let's say I have 3 points here, okay? Let's say I have 3 points. When I join them, I get the side of this, all the 3 sides. And then based on that, I can find out the area, perimeter, whatever I have to find. Yeah? That's what we do with geometry, right? You have some shape, you try finding out area, perimeter, whatnot. Here, let's say I have 3 points. When I join them, it becomes a triangle. So I need to find out the length of the side. Are you guys with me? But how do I find the length of the side? This is, let's say this is what? 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is probably 4, 5. And this point is probably, let's say 1, 2, minus 1, minus 2. Can you keep quiet for a little bit? So this becomes 2, minus 2. So I know the coordinates of these 2 points, okay? If I had a 3rd point, I would have found the coordinate for that also and then found the length. But my problem is this. I know these 2 points, the coordinates of these 2 points. But how do I find what is the length from here to here? I know 2 points. Okay, you guys are getting my question, right? My problem right now is I know 2 points and the coordinates of these 2 points on the coordinate plane. I'm trying to find out what is the distance between these 2 points.
So
No, don't give me anything in air. How? Tell me the concept part of it. How?
So basically, so if you have that much distance, you can count like each way how you like each number.
I can tell you that you are not going the right direction, so I will not entertain you right now. Okay. Any other thoughts? And again, I did not stop you because I did not like your answer. I stopped you because you were going the wrong direction. That would have not helped us get to the point. Okay. Let's see what Dikshita has to say.
I think it's 8.
No. It's not. I mean, I don't know. I don't want to get the answer from you. What I want to know is how would you find that out?
So basically what I did is you have to find the length. So so we stopped at 2, negative 2. So I counted from negative 2 to 4, 5. So I get 8.
No, I think that is not the right approach. Hold it. Let's see what we want Rihan has to say.
Since it's going like down down vertically, I'd say like you'd have to somehow get to like 5 to -2, which would get you 7, and 7 point something because the x value is different.
Not the right direction, so I'll probably let's see what Ritika has to say. Yeah, Ritika.
Like I would have like made like a right triangle, so like I would have like drawn like a line and like made it into a right triangle and then use like the Pythagorean theorem to find the third side.
Awesome. I love that.
What do you should
You are going the right direction. So see, Ritika has already taught me what I have to do, so my job is done. Okay, let's see what Tanu has to say.
Okay, so y2 minus y1 over x2 over x1.
What does it give? That gives you the slope. I need the length. No, I mean, see, again, you're thinking about it. So, Arav, can you stop that parallel thing?
Oh, I'm gonna.
So what you can do
This is your paper.
is that you can add like the y units, so like -2, and you can go 2 units up. And when you add 5, that gives 7 units. So
Okay.
that is
No, so, okay. I got.
I found it out. So basically, you can go up. So you got a -1.
No, so stop it there. You're wasting my time and everybody else's time right now. Because that approach is not going to work. I heard, see, I clearly told that Ritika has already taught me what I wanted to learn.
I'm not easy.
So, okay. No, it's not about that. I'm saying, see, this is a group, this is a team. All of us together, we are trying to learn something. Be it me or be it anybody else in the class. Ultimately, as a group, we should learn the right thing. So, that's what we are trying to do. Now, can I have everybody's attention for next 20 minutes? Uninterrupted, undivided attention. Look at these two. Now, I'll keep it simple, okay? Okay? I'll not say it again. Can I have your attention here? This is one point, and this is, let's say, another point. I'm trying to find out the length of this line from here to here. Descend to the 2 points, okay? Meaning, I want to find out this length. Now, let's look at what are the coordinates. 2, 2, 2 here, 2 here, 1, 2, 1, 2, okay? And then what is the coordinate here? I'll probably draw perpendicular so that becomes my easy. Okay. So this is 3, 4, sorry, 1, 2, 3, 4, 5. And this is 2, 3, 4, 5. So this is 5, 5 probably. Yeah. So I've done not anything. I have just drawn these 2 points. I'm trying to find out the coordinates of these 2 points. Okay. If I have to find out this length, remember what Ritika said. She said that we'll make this like a right angle triangle. So this is 90 degrees. So I just draw a perpendicular on this line. So if now this looks like a right angle triangle, right? If I look at this A, B, and this point is C, this is right angle triangle. This is one side, this is another side, which is making 90 degree, and this looks to be the hypotenuse of that right angle triangle. So this square plus this square will be equal to this square. Is it making sense?
Yeah.
Ritika, this is what you wanted to teach me, correct?
Yeah.
Okay. See, Ritika also acknowledges that she is teaching me, and I love that. When you guys start teaching me, my job is done. Alright, so coming back to this, but don't teach me wrong things. It will be bad for me to learn wrong things at this age. Alright, coming back here. Advik? No. Now, if I know this length, and if I know this length, I can apply Pythagorean theorem to find out this length. Agreed? Everybody agrees?
Yeah.
Now, what is this length here? If this is 2 comma 2, meaning this height from in the x and y direction is 2 and 2. If I have to find out this length, that will be what? This length minus this length. That will be by this length, correct? This part, AC, if you have to find out, AC is this length minus this length. That is by this length, correct? If I have to find out this length, which will be what? This length from here to here minus this length. If I deduct this part, this becomes by this length, correct? Can you guys see it and appreciate what I'm trying to say?
Yeah.
No? No? Okay, okay. So I'll repeat. No, that's okay. That's a very honest statement, right? I'm trying to say this is my right angle triangle ABC. For me to find out this length, what I need to find out is this length, and then I can apply Pythagorean theorem. Guys, calm down, and I would not say it again. So in this right angle triangle, to find out this length, if I find this length and this length, then I can apply Pythagorean theorem. Let's say if this is A, this is B, or this is, let's say, K, and this is L. So this square plus this square will be equal to this square. So I have to find out this length. I am trying to say how will I find this length? This length is nothing but this length minus this part. Is that okay, Dikshita? Similarly, if I have to find out this length, that will be nothing but this length minus this part. Yeah? So here in this case, if I have to find out AC, AC will be equal to what? Let's say this point is, I'm saying 2, right? So 2 to C. I'll give it a name, otherwise you will find this point to this point. M to C minus M to A.
Where's M?
I have given this point as a M.
Okay.
To M to C minus M to A. This gives me this length. Okay. Now, if I have to find out this length, which is BC, here to here, is nothing but this whole length minus this length. Let's say this is N. This point is N. So this equals B to N or N to B, whatever you call it, the whole length minus this length, which is N to C. Yeah? Tanu, are you with me? Yeah? Myra, Lochita, are you guys able to follow me as well?
Yes, sir.
Okay. Now, so here, Advik, you have to stop.
Okay.
So, I'm trying to find out this length and this length. This length is nothing but this length minus this part. So, M to C minus M to A gives me this length. So, M to C is what? Tell me now, how much it is? M to C is what? 5. So, this is M to C is 5 minus
2.
this much is 2. 5 minus 2, that gives me 3. Similarly, how much is this length? This minus this. So here to here is what? Again 5 minus this part.
3.
Again 2, which gives me a 3. So I got AC and BC. 5 minus 2, 5 minus 2 here. Now imagine a situation. Let's make it a gym. So now I got this length is 3 and this length is 3. I'll do square root of 3 plus square root of 3 will be square root of this, and then I can find it out. Now I'm not happy with that. I'm trying to make this more generic. Now imagine this one. You have 2 points. Here your x coordinates are x1, y1, and this is x2, y2. So that means when these coordinates are x1, y1, you will say here to here is x1, here to here is y1. This is x2, y2, meaning from here to here is x2 and here to here is y2. Do you guys agree or you don't?
Yes, I do agree.
So we have 2 coordinates. I am just telling you what is the length. This thing, yeah?
Okay.
Based on the coordinates. Now, I'm making a generic formula. So if I have to find out this length, what I have to do is find out this length, square of this plus square of this will be equal to square of this. Okay. Now this length, let's say this is C. So A to C, here to here will be what? This minus this, which is x2 minus x1. Yep. B to C will be equal to this minus this, y2 minus y1. So this length is x2 minus x1, this length is y2 minus y1. If I have to find out this length will be equal to, this square will be equal to this square plus this square by Pythagorean theorem. So AB square will be equal to AC square, which is x2 minus x1 square, plus BC square, which is this one, y2 minus y1 square. Or AB will be equal to square root of x2 minus x1 square plus y2 minus y1 square. This became a generic formula. Now I know everybody must be scratching their head, and don't do it much, otherwise you will lose your hair and become like me. Don't scratch, think about it. We pick 2 points which has coordinates as x1, y1, x2, y2. What x1, y1 means? That this length is x1, this length is y1. Second point is x2, y2 mean, what does it mean? This length is x2 and this length is here to here is y2. Okay? So we are trying to find out that this length. So what did we do? We just extended this, made this a right angle triangle, and now we are trying to say, okay, for this length to find, I need to find this length and find this length and then apply Pythagorean theorem. This length is what? This whole length minus this one. This whole length is x2 minus this one is x1. This is this length. This length is this whole length minus this part. This whole length is y2 minus y1. So we got this length is x2 minus x1, this length is y2 minus y1. Now I can do square of this plus square of this will be equal to square of this, and hence this will be equal to square root of this. This becomes your formula called distance formula.
Distance formula?
That's very good.
That's a long formula.
It's not a long formula, you have to always, there's a deal. The deal is between brain and mouth. Either of them work at a time. I'll call your daddy for sure tonight. A guaranteed call. Okay? For both of you. There's a message for both of you. There's a difference in degree, but I'll call. Yesterday also I had a call, talk with him. Today also I'll call. Okay? And I promise. Now coming back to this theorem, this formula. What did we do? Again, repeating it. I had 2 points. x1, y1 are the coordinates. x2, y2 are the coordinates. We are trying to find out the length of this one. What did we do? Same thing. x1, y1. This length is x1, y1. This length is x1. This is y1. For x2, y2, this length is x2. This is y2. So we have to find out this length plus this length and apply Pythagorean theorem to get this one. So this length is this whole length x2 minus x1. This whole length minus y2 is this length. So x2 minus x1, y2 minus y1 is square of that, which is square of this. So this only this length will be equal to square root of this value. Now if you look at it carefully, what does it say? If you have 2 points and you have to find out the distance between the 2 points, subtract the x coordinate, later value minus the earlier value, square of that, plus y coordinate, later value minus earlier value, square of that, and find out the square root. This is called your distance formula. So summary is, if you have 2 points in a coordinate plane and you have to find out the length of that line, which is joining the 2 points, this applies this formula. x2 minus x1 square plus y2 minus y2 minus y1 square, the square root gives you this, which is called distance formula. And you will apply this formula for derivation of any length between 2 points in a coordinate plane. Is this clear or not clear? Gitesh, Lakshita, Myra, Ritika, Arihan, Nihan. Okay. If you guys play with that, I will also play with that. Huh? Okay. Alright. So don't do that. Let's come back to doing a serious business. Okay. Now, you guys learn the distance formula. So tomorrow, not tomorrow, we don't do class tomorrow, we do it today. So we'll settle it today. If I say there are 2 points 5, 2 and 11, minus 8 or 11, 8, let's say. Find out the length of this line joining these 2 points. Or find out the length of the line segment joining these 2 points. Who can find it out real quick? I don't know what Thanu is enjoying right now. I can see he's smiling, talking to somebody, I don't know what, but I see him very, very busy. But anyways, I don't mind that thing. What I'm saying is, we just learned the distance formula. I want you guys to apply the distance formula and find out the length of this line segment, which is joining these 2 points. And I would want everybody to try that. Nihan, Arihan, Ritika, Myra, Lakshita, everybody. Dikshita, yep.
Oh, which is the x1 and which is the x2? Y2?
That's a $1 million question. I can answer that real quick, but I'm not doing it. Now you will tell me why. You'll tell me why. Okay. So see, I'm forcing you guys to think. Yep.
I got 18 squared.
Okay. You got the answer anyway. So here, just keep this thing as an information, okay? x2 minus x1 squared or x1 minus x2 squared. Both will always give you the same value. It's a square of the difference. Okay? So don't worry about it. It will not hurt. Whether this one is x1 or this one is x2, doesn't matter. Yep? Alright. So I gave you guys a clue. So apply that and let's see what happens. Yeah, Ritika.
Wait, I got an answer. Like, so should I say?
Yes, please.
I got like 6 root 2.
6 root 2.
Like square root is 72.
The square root of 72. That becomes 6 root 2. Yeah, okay. That is one of the answers. You gave me square root of 18? Okay. Yeah, Dikshita, how much did you get?
I got the same thing.
Same as in which same? Advik same?
Square root of 72.
Okay, that's Ritika's same. Okay, how about you, Thanu?
I got the same answer as Dikshita.
Okay.
I got the same answer.
Did you get the same answer as Ritika also?
Yeah.
Okay, okay. Now I was just checking if we are all paying attention or not. Okay, yeah, how much did you get? How much did you get? Yeah, Pranav, what was your answer?
I got 72
Square root 72. You got 72. So, see, this is fairly straightforward. Okay? So I was saying that, I mean, I don't know whether 72 is right or 18 is right. Square root 72 or 18 is right. We'll figure it out. But what I was saying was, we learned this formula. The distance formula says the length between the 2 points AB is nothing but x2 minus x1 square plus y2 minus y1 square. And here, I don't know which one is x1, which one is x2. In one case I will assume this one to be x1, x2, x1, y1, x2, y2, and another case I will assume this to be x1, y1, x2, y2. Okay, and we'll see if the answer changes. Okay,
Does it really matter?
we'll just check. This one, let's say this is x1, y1 in the first scenario. Okay, and this is x2, y2. So x1, x2 minus x1. x2 is 11 minus x1 is 5 squared plus y2 minus y1. 8 minus 2 square root of that. This gives me 11 minus 5, 6 square, 36. 8 minus 2, 6 square, 36. Fine. 6 root 2. So all of you who got 6 root 2 was the right answer. Now I got little mischievous. I thought, okay, how about I treating this as x1, y1 and treating this as x2, y2, and what happens? Here my picture will change. This is x1, y1 and this is x2, y2. So y2 is 2 minus y1 is 8.
That should be 5
x2 minus x1. So x2 is 5. No, 5 minus x here is 11. And y2 minus y1. y2 is 2 minus 8. So what happened was it became 5 minus 11 minus 6 square plus this one 2 minus 8 is minus 6 square.
As soon as everything, because
So-
goes positive.
Okay, hold it there. I got it. I'm just collating it, okay? So minus 6 square gives me 36 and this minus 6 square so gives me 36. What did we observe is whether you treat this as the first point, this as the second point, or you treat this as the first point, this as the second point, doesn't make a difference. That is what I was trying to conclude, okay? Because it's always the difference of the coordinates squared. So 2 minus 5 versus 5 minus 2 is the difference is 3 and square of that will give you the same value. If you are picking the smaller number first, you will get a negative value, square of that will give you a positive. If you are picking the larger number first, you will get a positive value, but the difference will give the same value. So what I am saying is, we should not be worrying about which one to keep as x1, which one to keep as first point, which one to keep as second point. Yeah. Otherwise, you all have already seen how this distance formula is derived and how to apply that. That should not be a problem. You just have to be mindful of how do you choose to do the calculation and where not to worry about which point I am picking as the first point versus the second point. Yeah. So now coming back to the earlier discussion that we had when I had given you guys that I have 2 points like this and this, 5 comma 2 and 2 comma minus 3, something like that. And when you guys were trying to find out the length of this one, we had different thoughts around this one, but now those thoughts are not to be trusted. We can always use our distance formula to derive this. Is this understood by everybody? Any doubt, any confusion, anything else about this concept so far? No confusion? Okay. So, Lokchita, Myra, Nihan, Arihan, everybody clear? Pranav? Not clear? Or clear?
No.
Clear, okay. Alright. What is that?
I think a glitch, sir.
Okay. I heard no 3 times, so that was making me think that do I have to do it again? Now there is something called section formula. Section formula. So if I have 2 points, let's say this is x1, y1, this is x2, y2. If I say that if I join these 2 points, okay, and find a point such that, a point on this line such that this divides into 1 is to 2. Find out the coordinate of this point. Again, let me repeat. Don't get scared. I'm not trying to scare anybody. I'm saying that I know there are 2 points, x1, y1, x2, y2 on the coordinate plane, and when you join them, it becomes a line segment. Find out a point, or find out the coordinate of a point on this line which divides this line into this ratio 1 is to 2, or 2 is to 3, or 3 is to 5, whatever it be. How will you do it?
I have no idea.
Yeah. Tanu, are you talking to somebody? I see a lot of lip sync happening in the background.
It's just my friend. He's helping me with the math class.
Okay. Okay. That's okay. So coming back to this one, I'm saying that if you have 2 points, let's see how much time do we have. We have 17 more minutes. If you have 2 points, x1, y1, x2, y2, when you join these 2 points, you get a line segment. So let's say, now you know that, okay, if this is A and this is B, you know how to find out the length of AB. You know that, okay, AB, length of AB will be equal to the square root of x2 minus x1 square plus y2 minus y1 square. Okay. But, like always, your teacher is not happy with what we have learned so far, and he is wanting you guys to learn something more and make life more complicated. So I'm saying, no joke, pay attention here, otherwise my call might go back. Here, on this line, if somebody says, find out the point on this line so that it divides this line segment into 2 parts, like 1 is to 2. So find out the coordinates of this point. How will you find it out? I'm not trying to solve this problem, but I want you guys to think and tell me what comes to your mind. And I don't need an answer right away. Take 30 seconds, take a minute, and then give me a response. How will you go about it? You have 2 points, join the 2 points. The question is, what will be the coordinate of a point on this line which divides this line into 1 is to 2, or 2 is to 4, or 3 is to 9, whatever it be? How will you find it out? Any guess? Pranav, any hand? Ritika, Nihan, anybody? Yeah, Ritika.
Like maybe you would find like the length of like A to B and then like divide it by like 3 and then you can like use that. So I'm not really sure.
No, but see, I'm forcing you guys to think, right? Because once you think, once you start visualizing, that will give us more clue. So the question here is this. I have 2 points. When I join them, I get a line. And by now we have learned how to find out the length of the line. Somebody said, okay, on this line, can you find out the coordinate of a point which will divide this line in a certain ratio? Yeah.
I think we divide by 2.
What is that?
I think we divide the equation by 2.
No. Okay, let me give you guys some more food for thought. This is my line. Let me make it visually more appealing. So this is my x-axis, this is my y-axis. Okay? Now add more color to it. So here to here this length is how much? X1. No denying that. Here to here what is the length?
X2. No, Y2.
Y1.
No, Y1.
That's why always give yourself some time to think. Okay. Now, so we got this is x1, y1. It's no brainer, right? We know x coordinate is the length along the x-axis. Y coordinate is the length along the y-axis. Now, What is this length?
x2.
X2. And what is this distance?
x2.
Y2.
Y2.
I2.
Yeah. Yep. So we have not done anything fancy so far. But let's assume this is the point, okay, where the coordinates are x and y. We'll find out what is the relationship here. What we have done is, I've just joined the points to make this look, see this is a right angle triangle now, this is a right angle triangle as well. Yeah? And what is the length from here to here?
x3.
No, this is x. These coordinates are x and y. This is x. Okay? What is the value? What is the length of this line?
y.
This is y. So, when you look at this diagram right now, these were my 2 points, and I'm assuming this is the point which is divided into 1:2. So, this might be a very loaded thing. This is called section formula. Okay, I will try proving it, but if you guys get stuck somewhere, if it looks overwhelming, we'll only focus on the formula, and maybe by next year when you guys feel a little more comfortable, we'll come back to this again. Okay? When I say next year meaning, I'm talking about the next school year. Okay? So this might be a little loaded concept, but let's see how much we understand. Or we don't do that. Shaking the table will not help you understand the formula in an easier way. So don't do that. Now, this is one length. Okay, let's give it name. Yep. Somebody saying something? So this is AB and this is my spine C, which has coordinates x and y. Let's give some name to these points also. Let's say this is D and this is E. Between this triangle CBE and triangle ACD, what do you see? Is there something that you can make out or assume based on what you see on the board? Is there a relationship between these two triangles? What? Yagitesh.
They're both right triangles.
Say that again.
They're both right triangles.
They are both right triangles, agreed, because we purposefully dropped the perpendicular line, so they both have 90 degrees, so that's a good observation. Yeah.
They both share the same hypotenuse.
They both share the same hypotenuse, no? This is one hypotenuse. This is another hypotenuse, right? This CB is the hypotenuse for this guy. AC is the hypotenuse for this guy. So they are along the same line, but they don't share the same hypotenuse. The hypotenuses are different. Yarihan, what else do you observe?
All three of the angles are the same.
One more time.
I think all three of the angles are the same for both of the triangles.
Both of the triangles. Why do you think so?
It's by the way it's portrayed, it just looks like that.
It looks like that, but I mean, see, I'm just forcing you guys to think a little bit more mathematically here. Any other thoughts? So let me give the clue here. Arihan said that both the triangles have matching angles, and I agree to that. Not visually, but mathematically. I want somebody to break it down for me. Okay. Yeah.
So a triangle's all of its angles add up to 180. And so in a right triangle, half of it is already gone because of the 90-degree angle. And so we only have 90 left. And when you see the right triangle, both of its angles should be the same. So they both have like 45.
No. You were thinking in the right direction, but you lost the track halfway through. Let's see what Arihan has to say.
I think they have the same angle because they are like a part of the same line, really, and the line is going in the same angle throughout.
Not convincing enough. Anybody else wants to give it a shot? So let me give you guys a clue. First of all, this angle and this angle are matching because both are 90 degrees. So one angle has already matched between the two triangles. Now it's a question about these two angles, this one, and this one, and this one, and this one. I'm asking you guys to figure out if there is a way by which you can tell me that they have other two angles also matching. Any thoughts? Dikshita, Myra, Nihan. Stress out your brain cells a little bit more, you'll find the answer. Yeah, Gitesh.
Are we using any of the side, angle?
No, so that is for congruence. I did not say that. We are just trying to find out if the angles are same or not, right? And you cannot use side. There is no information that you have. Yeah, Yatanu. What does your brain cell say?
I made an observation, like the top triangle is just the same triangle on the bottom.
You got muted.
I think the top, I made an observation, the top triangle is like the top triangle and the bottom triangle, they're like the same, but the bottom triangle is smaller than the bigger triangle.
I mean, that could be a good observation, but you're relying way too much on my drawing skills. Okay, let's see if Ritika, Dikshita have something to add. Lakshita, anybody? Ritika, can you try giving me some clue? I'm dying to hear one good observation from any of you.
I don't really know, so.
Okay, see, now, yeah. Don't mind. No, it's okay. Now look at these two lines. Okay, no, now that option is exhausted. Okay, what is that?
They're both made out of marker.
No. These are the reasons why I get tempted to call parents, right? Yeah.
I'm not wrong.
So now look at this. This line and this line are parallel, aren't they?
Yeah.
This line is kind of intersecting both the lines. This is a scenario of two parallel lines being intersected by a third line, isn't it? These two parallel lines being intersected by a third line. What does the parallel line say?
They're equal.
Yeah. Who has raised hand?
I was gonna answer the question, but something tells me you're about to answer it yourself.
Okay. So when we have two parallel lines being intersected by a third line, their corresponding angles are same. Look at these two parallel lines and the third line intersecting them. What are corresponding angles? This one and this one are corresponding angles, aren't they? Yeah? So the corresponding angles are same because these two are parallel lines and this is a third line intersecting both of them. So you had 90 degree and 90 degree matching. You got one more pair of angles matching. Do you think the third angle, this one and this one, have any other choice but to be same? Yeah? So essentially what happened was, we had a line where we had x and y coordinates, and we assumed that this is the point on the line which has coordinates as x and y, which is dividing this line into ratio 1:2. And can you stop? I don't need any noise. Don't make any noise. So from here we draw perpendicular lines, and by doing that we found there are two triangles, this small triangle and this triangle, and they are similar. When you have two triangles similar, what does it mean? What does it do?
Makes them the same.
Don't rush. It is told scientifically that when you are eating, you should chew it 32 times to get the best digestion possible. Similarly, I have told you guys probably 100 or 200 times that don't rush for giving a wrong answer, because wrong answers have no worth. It's okay to take 10 seconds, think, and then give a right answer. So my question was, if there are any two triangles similar, what do we infer out of that information? What is the relationship? If the two triangles are similar, meaning they have matching angles. See, when we ever say the two triangles are congruent, what does it mean? All their properties are matching. Their sides are matching, their angles are matching, their area matches. They don't have a choice. They have to be exact copy of each other. But when we talk about triangles being similar, what does it mean? Only angles are same. Only angles are matching. And what is the second thing? You should recall, their sides are in the same proportion. Okay? Their sides, meaning, let's look at this triangle now. Now we found that this triangle CBE and ACD, CBE and ACD are similar. We found that out. And we found that this angle, if I call this as 1, this is also 1. If I call this as 2, this is also 2. If I call this as 3, this is also 3. So we know which angle is matching with whom. So now when the two triangles are similar, their sides will be in the same proportion, meaning the ratio of the sides, meaning this side by this side, because both are opposite to 90 degrees. AC by BC. This ratio will be same as, now look at another angle. Let's say 2. Side opposite to that is what? CD. CD, AC, CD divided by BE. This will be equal to, let's take the third angle. Side opposite to that will be AD divided by CE. So far I have not proved any formula, okay? What I am saying is, this was the side, this is the point which is dividing this in this ratio, and then from that we derive these two triangles, and now we know that, okay, AC, when you have two triangles being similar, their sides are in the same ratio. Now look at this, AC by BC, we already know the ratio, 1:2. 1:2 equal to CD by BE will be equal to AD by CE. I can break it down and I'll explain that later on also. But here what the clue is, this will help you define a new formula which I will define in the next class. I think we are already on the top of the hour. This helps you define a new formula. Just give me a minute to write this down, okay? And I'll prove that later on. It says x equal to m1 x2 plus m2 x1 divided by m1 plus m2.
What's
Y equal, hold it, m1 y2 plus m2 y1 divided by m1 plus m2, where this, if this is m1, this is m2. It will not be always 1:2. So this becomes a formula which is called section formula, and that will come from this, okay? I will just need to spend 5 more minutes to explain this, which I'll do in the next class, okay? I don't want to stretch your class now. But summary of this is, if you have a line and you have to find out a point, the coordinate of a point which divide this line into certain ratio, m1:m2, this is how you find out the coordinate of this. Tomorrow something says, okay, it divides into 5:3. So m1 is 5, m2 is 3. And you will put the value here and you will be able to find out the coordinate of this point.
What's M?
M1 and M2 are the ratio. Here I have said 1:2. I am saying it's M1 or M2. So this is called a section formula, which might look very complicated to begin with, but actually it's not. We'll learn that. I will break it down. I'll explain that to you, how from this one it came to this one. Okay? Alright? So, a little loaded class, but good thing is we learned the correlation between coordinate planes and geometry, how they come together. We learned how to find out the distance between 2 points. And then, if you have to find out the coordinate of a point on a line which divides a line into certain ratio, this is the formula that we will use. How this is derived? We'll probably need 10 minutes to derive the next class. Yeah? Alright? With that being said, I will let you guys go. Anything that is bothering you. I'm sure this formula must be bothering some of you, and it's okay. It's okay if it bothers, because that is what will give you an opportunity to dig into it and make sure that becomes easy. At least with the distance formula, I'm assuming that you guys are fine, right? Yep.
It says low battery, which like